Texan Global School. Relations between lines. In this class, the relations between two straight lines are analyzed. Given two straight lines defined as a, x plus b, y plus c equal to 0, and a prime of x plus b prime of y plus c prime equal to 0. The analytical conditions in which the lines can behave are parallel, perpendicular, lines that coincide, or lines that intersect in one and only one point. For the first case, the parallelism condition says that two lines are parallel if their slopes are equal. As we saw in previous classes, we can obtain the slope from the general form of each of the lines, which are given as negative a over b and negative a prime over b prime respectively. Applying the condition of parallelism, we obtain the relationship between the coefficients as a over a prime is equal to b over b prime, or any equivalence that can fit the equation. For the second case, the perpendicularity condition says that two lines are perpendicular if the product of their slopes is equal to -1. Likewise, using the relationship to obtain the slope of a line from the general form, we can apply the perpendicularity condition and obtain the perpendicularity relationship between two straight lines as a times a prime plus b times b prime equals 0. Now, two straight lines coincide if they have the same point in common and the same direction or slope. From the general form of a line, we can determine its slope and intercept as seen in previous classes. The intersection or common point of the lines with the intercept on the x-axis, in such a way that we use equal value with the abscissa obtaining a over prime equals c over c prime. Likewise, since their direction or their slopes are equal, we can also use equals value to the slopes obtaining a over a prime equals b over b prime. In this way, two straight lines coincide if their corresponding coefficients are proportional. Specifically, each proportion can be written as a non-zero constant k. We can rewrite the relations as a equals k times a prime. B is equal to k times b prime. C is equal to k times c prime, thus obtaining true relationships for all cases. Finally, we know that geometrically, two lines intersect at one and only one point if they are not parallel. In this way, we obtain the same parallelism condition but as a negation. In summary, if the equations of two lines are given by their general forms, the following relations are necessary and sufficient conditions for parallelism, perpendicularity, coincidence, and intersection in one and only one point. Let's look at the first example. The equation L is x minus 2y plus 1 equals 0. We must write the equation that represents all the lines parallel to L. From this last equation, let's find the equation of the line parallel to L that passes through the point P with coordinates 1, 2. First, use the parallelism condition where a over a prime is equal to b over b prime. Replacing the coefficients a equal to 1 and b equal to -2 of the general form of the given line, results that b prime is equal to -2 a prime. Now, if we represent the equation of all the lines parallel to L as a prime x plus b prime y plus c prime equal to 0. Substitute the relationship obtained from b prime as -2 a prime. When developing, results the equation x minus 2y plus c prime over a prime equals 0. This is the equation that represents all the lines parallel to L. In this way, the independent term determines the constant k equals c prime over a prime, thus obtaining the equation x minus 2y plus k equal to 0. Since the parallel line to L must pass through the point P with coordinates 1, 2, we have that x equals 1 and y equals 2. Substituting the values to obtain the k results that k is 3. Therefore, the parallel straight line that passes through the point P of coordinates 1, 2 is x minus 2y plus 3 equals 0. We will graph to verify the behavior of the lines. First, isolate y from both equations. Now, propose two values of x and substitute to obtain the value of y. In this way, we obtain the tabulation with its coordinates. Then, plot to see the behavior of the straight lines, thus verifying that they are parallel. In this other example, let's find the value of k, so that the line k, x plus k minus 1 times y minus 18 equals 0 is parallel to the line 4x plus 3y plus 7 equals 0. From the general form of the line a, x plus b, y plus c equals 0, identify the values of the coefficients. Then, obtain the slopes of both lines with the relationship m equals negative a over b. For the first line, we have that the slope m is equal negative k over k minus 1. For the second line, the slope m is negative 4 over 3. Applying the condition of parallelism, where the slopes are equal, results that k over k minus 1 is equal to negative 4/3. When solving, results that k is equal to 4. One way to verify is to substitute the value of k into the equation, and graph both lines to see that they are parallel. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com